Right. Well, hello, everybody. Welcome. Thank you for joining today on our DEI seminar. Today, we've got Professor Alejandro Caparros, who's going to be talking to us about gradual international climate policy. Alejandro is a professor in our economics department, and he's professor of energy economics. He's also the co-director of the Center for Environmental Energy and Economics. He's worked on multiple different projects, including recently he was the lead author for the IPCC on the sixth assessment report on the theme of international cooperation. And he applies microeconomic tools to analyzing negotiations on climate change. So thank you so much for coming to talk to us today. Just a quick summary on how this will work. Alejandro will talk for half an hour to 40 minutes-ish. During that time, if it's all right, if everyone can turn off their camera and mute themselves. If you have any questions as you go, just pop them in the chat. And at the end of the talk, we'll open up for questions and look at the questions in the chat and give everyone a chance to ask their questions. So thank you very much. And I'll hand it over to you, Alejandro.
So thank you very much for the nice presentation. And I'm going to be talking, as mentioned, on gradual international climate change policy. Some parts of the talk will slightly technical, but I will present some of the formulas, but don't go into the details at all. And in all cases, I will just discuss more the intuition and discuss the graphically what we try to say. So, well, from economists, of global change is the most significant environmental externality and the ultimate challenge for economics. That was not said when he received his Nobel Prize working on climate change economics. So it's a very big problem which has many implications, and for us economists, it is seen as an externality, a huge externality, a huge public good, where you have to try to solve it. And for that, we have had several agreements. In 1992, as many of you know, the United Nations Framework Convention on Climate Change. Then in 1997, the Kyoto Protocol, and now we are in the Paris Agreement. In 2015, it was signed and ratified soon after. So I'm going to be talking mainly about comparing a little bit the Kyoto Protocol and the Paris Agreement and how we can use some of these lessons in a more gradual process. So, well, as you know, of course, climate change, the reason why we are trying to stay below 2 degrees is that we don't know what is beyond that, basically, as humans, because for hundreds of thousands of years, our climate has been below this +2 degrees from the industrial levels. And actually, in the Paris Agreement, as you know, the goal is to stay below 1.5. This was not so much based on science. It was probably more a political thing that was decided to the surprise of many who were following the negotiation at the time. So the discussion were always on the build-up: are we going to include in the Paris Agreement 2 degree goals or not? There was a big discussion, but finally it was included, even the 1.5 degree. So we have pledged for very ambitious. So we have a very ambitious target, but it is not binding on international law, not even on international law. And we know.
Sorry, Alejandro, sorry to interrupt. We can't see your slides at the moment.
Sorry?
We can't see your slides at the moment. Sorry to interrupt.
Oh, no, that's important to interrupt, but that's, I think we were sharing the screen. It was before, stopped somehow.
There you go. Oh. Brilliant, thank you.
Now, let's see if we can put it to So are we now?
Perfect. Yeah, that's great. Thank you.
Okay. So well, anyway, as I was saying, talking on gradual international climate change policy. An important part of the work that I'm going to present today is joint work with Jean-Christophe Perrault from the University of Bordeaux in France. So we have climate change. Basically, I was simply saying that this graph here explains. It's a very well-known graph, simply saying, well, why we have this target of staying below 2 degrees is because for hundreds of thousands of years, we have been below that. So we don't know exactly what's going to happen above that. So in the Paris Agreement has even a target of 1.5. So this is what the IPCC, and that's the origin of many of these net zero pledges that we have right now, is that after the Paris Agreement agreed to have this target of 1.5, the IPCC was asked whether is it at all feasible to do 1.5. And the answer was yes, it is still feasible, but you have to be very ambitious. So basically what this graph is telling us, this part here, see the marking? Do you see the marks? Not in this, not doesn't work. Anyway, and the pointer here you see. So here it's our historical emissions. They have been growing up to now globally. There have been efforts in different areas. There have been efforts in the UK. There have been efforts in the European Union. But globally, our emissions are still growing. By 2020, they never stopped growing. So here, this graph, as I said, was produced in 2018 by the IPCC. Is basically, let's ask a central planner. Imagine the world has a central planner. How would you deal with this problem? Taking into account already benefits and costs. This is already a benefits and cost analysis, not just focusing on how to solve climate change, but how to do it efficiently from an economic point of view. And basically, what they're proposing is go down as quickly as possible with your emissions and be zero by 2050, and then become negative in the second part of the century. Becoming negative is extremely difficult because for the moment, negative emissions, we only have the only proven technology that we have for that is plant forest. We have some other technologies in the pipeline, but the only one that's really working to be negative in terms of emissions is to plant forest. And this is a huge amount of forest to be planted. But the main message coming out from this graph, basically from the whole report that the IPCC made in 2018, is that we have to be net zero by 2050. And now we have many pledges in this direction, but always only pledges, basically. What is the black line? The black line is saying, okay, we have from the Paris Agreement the pledges that different countries have made, and they are not following this path here, A, they're actually following this black path. So it is true that if the pledges are met, emissions are going to go down for the first time from 2020 to 2030. That's what we expect it to occur. So if countries follow their pledges, this will happen. Then the question was again, what would you do as a central planner if you arrive at this point in 2030? And again, the answer is to go down as quickly as possible. There are some details of different models, but the basic message is always there. So we have to reduce our emissions as quickly as possible in a relatively short period of time to be net zero at the global level. It is important this has to be achieved at the global level. So this is another graph. This is from the Climate Change Action Tracker, saying again, basically the same thing, more detailed. Here are our historical emissions going up, and we have to reduce them very significantly to meet this general target of 2050. So that's now more in detail what we should do by 2030. So it's more or less focusing on this area here, what we should be doing by 2030. And again, it should be a very strong reduction. And what we are seeing are pledges which imply a slight reduction. Here there was a change from 2020 to 2021. That was at Glasgow. We had some additional pledges, so we're a little bit better, but we're still very, very far away from where we should be. If we're meeting our 2030 targets and afterwards our 2050 targets at the global level. I insist it's different for countries like the UK or the European Union. So this is a graph from the last IPCC report. It's actually a graph I produced, and it shows that I'm not very good at making graphs. It's very simple, but it also shows how far we still are, even if we meet our pledges. So, and how important international cooperation is to be able to meet our targets. Because we have, to some extent, climate change policy after the Paris Agreement has become a national issue. And most countries discuss it nationally. So they don't so it's less important now, the international discussion on climate change, if you want, as it was during the Kyoto Protocol and on the run-up to the Paris Agreement. Now most countries are focused on doing the climate change policy independently and meeting their pledges at best. But let's see what would happen. So this is, if we want to stay below 1.5, we have to reduce all these emissions from now to 2030 by 2030. The gray area is what countries have pledged to do independently of any support of any international cooperation. This is basically what the European Union, the UK, United States, the developed countries have said they will reduce their emissions, this gray area here. It does not depend on international cooperation because they said they're going to do it, and most countries are on track of doing that right now. Then we have this blue area. This additional blue area is what the developing countries basically have said they will do, but only if they get international support. So all this blue area depends on getting international cooperation going. So on having emissions, there will be an additional emission reduction, but only in exchange of transfers, in exchange of technology. So there are conditions. As I said, the gray area is basically developed countries, blue area is developing countries. In most cases, they have asked for something in exchange. We are not really seeing a lot of that. We discussed a few examples of these agreements going on, but they are not a lot of them. And then we have all the orange part, which has not been pledged even by any country. So we have huge amount of emission reductions to be done by 2030. It is by 2030 as well. If we want to be on target globally of a 2050 net zero and negative afterwards. If we're looking for staying below 2 degrees, it is of course, well, what has been promised the same thing, but we have less which has not been promised. So basically we have, as I say, in ways international cooperation important. Well, for the blue area, we will definitely need it. And it's also important for this orange area because this has to be a combination of more ambitious national policies and more ambitious international policies. So the main message here is that, yes, we have had climate change policy for quite some time, but the only thing that matters is that emissions are growing. Emissions are growing non-stop, and the only dips have been the financial crisis here and COVID. If you see it here, we had financial crisis. This is the negative part down here. We had COVID, very negative in terms of emission, big emission reduction, but that's obviously not what you want. And 1 year afterwards, they were up again, and also this last year, they are up. So you can see there's almost no effect of the Kyoto Protocol, the Paris Agreement is simply going up and up and up. So that means that our system is delivering in some areas. I would say the European Union and the UK examples where the climate policy is delivering. But at the global level, we are very, very far away from solving this problem. So as I say, we have the Paris Agreement is now what we have. This is under the umbrella of the United Nations Framework Convention on Climate Change. We have the Paris Agreement. The Paris Agreement is a very complex system. I'm not going to be giving much detail about it. I'm just going to highlight here that it has two features. One is this pledge and review, where you simply send what your pledge, so your national demand contribution, how much you're going to be reducing. But it also has an important article, which is Article 6, which is the cooperative mechanism. So this Article 6 is the one I will be focusing more on how to develop that, from a theoretical point of view in my case, but how important this one is, because that's the one where we can see something similar to what we had in the Kyoto Protocol. So really, binding agreement can be signed in there, and it can be where there is a distribution of effort, saying, I will do more if you do more, or I will pay you to do more. All these kind of things between countries, all these cooperative mechanisms can be done under Article 6. And they really need to be developed because, as I said before, that was the reason for the previous graphs. If we rely exclusively on national policies, we are simply not going to be meeting our targets. So we need to be beyond that the UK does net zero, that the European Union does net zero. That's simply not going to be enough to turn net zero at the global level. And that is the important thing. It only matters whether we get net zero at the global level, because this is a pure public good or where only total emissions might matter. So what is the Paris Agreement? Well, many of you already know it, but just in any case. So it has a long-term agreement. So it has goals for the second half of the century, stay below 2 degrees, so even if possible 1.5 degrees. That was subject to the unanimity rule, so it was approved with the unanimity rule. So then it requests each country to outline and communicate their post-2020 climate actions, so their national demand contributions. Countries, as I said before, have submitted conditional and unconditional NDCs, and the conditional are about as important in terms of total emissions as the ones included in the conditional are more or less as important as the ones included in the unconditional. So we need this additional cooperation to get this conditional actually done, because without international cooperation, all the pledges that were conditional will simply not be delivered. These were not subject to the unanimity rule, and these NDCs are simply recorded in the registry, which is publicly available, but and updated every 5 years, but they're not legally binding, not even under international law. That means they're just pledges, and it is not a burden sharing agreement. The Kyoto Protocol was. What do I mean by not a burden sharing agreement? So this is a comparison here as the example for comparing the Kyoto Protocol and the Paris Agreement. So if four friends go to a restaurant to have a dinner or maybe a lunch, it's a paella here. So they're going to have a lunch, and then they know that the bill is going to be £100. So one way of doing this is the burden sharing agreement. Is okay, we have to agree, we have to pay 100. So the one with the orange shirt says I pay 50, the other one 20, 30, and 0. For example, it's one way of sharing this burden. That was done in the Kyoto Protocol. So there was a goal of reducing emissions globally by 5%. This goal was shared only between developed countries, and it was shared 8% the European Union, 7 United States, 6 Japan. So there were different efforts, and they were negotiated. But basically, you were sitting on the table and negotiating how to reach a goal. Here, it is how to reach the total bill of £100. What is the Paris Agreement? The Paris Agreement, you don't really negotiate how to distribute the total bill. You simply ask everyone to send what they consider they should be contributing. So it might be the case that all of them send €5, £5, and we end up with £20, but we still have a bill of 100. So the Paris Agreement has the problem that if you focus only on the national demand contributions, there is no guarantee that you will be able to pay your dinner or that you will be able to reduce emissions sufficiently to stabilize our climate. So that's why it's important to have, in addition to the basic NDCs, more cooperation seen on the Article 6, where you can make afterwards within this umbrella of the Paris Agreement, they could make an agreement under Article 6 where they say, okay, we have sent these pledges, but now we are going to increase our collaborative efforts to finally reach this 100 because with £20 we're not going to have dinner. So, as I say, what is important is, for my talk in general, is this Article 6. Countries may cooperate voluntarily to increase the reach of their abatement targets, and there will be a significant amount of monetary transfer for developed to developing countries. So this, for the moment, we have at least 2 of these examples of bilateral agreements. There's the implementation agreement to the Paris Agreement between the Swiss Confederation and the Republic of Peru. There's a second one in Ghana. So these are 2 agreements which are in this line of bilateral agreements. And then we have, well, this is what I mentioned here by Kinley, Summit, Kutejar, Debo, and Figueres, is a paper where they say, well, now we have to move into the implementation. We have to move into this type of agreements. They are all the living former executive secretaries of the United Nations Framework Convention. And what I do in another paper, I'm not going to refer to today, is this pledge, talk about this pledge and implement. In that case, I focus on the situation where you have this Paris Agreement already, and now you have to develop this Article 6 to a set of bilateral agreements. But today, I'm going to do something which is slightly related, but it's not really exactly that. What I'm going to be talking is about a paper which became quite famous in economics and have a big influence on international cooperation. And it's a paper by Barrett, 1994. There are similar ones by Carlos Siniscalco. So they introduced what is a collision formation. And this paper has been cited very frequently in IPCC reports, and is actually down beyond economics to some extent, at least for people who specialize in international cooperation, even if they work in other areas which are not economics. They repeatedly say that economists have proven that only very small agreements are stable. So argument has been used very, very frequently to say the Kyoto Protocol was kind of doomed to fail because we cannot have large agreements that are self-enforcing in the sense that countries don't want to leave it. And because even under international law, you can always leave an agreement. That's actually what happened with the Kyoto Protocol. So the Kyoto Protocol, it was possible to leave it. And what happened is that just a month before the deadline, the moment where the countries had to commit to present the results in the commitment period, that's in November 2011, we had Canada withdrawing from the Kyoto Protocol. So you can always leave it. So in that sense, there's the argument that agreements have to be self-enforcing. So countries have to be interested in staying there. And the results from Barrett 1994, also Carraro Siniscalco, is that only a very small number of countries will have such a self-enforcing agreement, be able to do such a self-enforcing agreement. Soon what will happen is the free rider incentives kick in, and it's better to have others doing that. So as I say, it has we were writing this report for the IPCC, so the chapter International Cooperation. We were only a couple of economists, but many of the others who were political scientists or sociologists, etc., they referred to this paper by Barrett 1994, kind of saying, okay, economics shows, they're always talking about this kind of paper. So here I'm going to discuss a bit more of this paper and really see where it's actually this result is robust and to what extent it is. So it's a one-shot game. It's a very simplified game. So from now on, everything is very simplified. but I'm going to make it a little bit less simplified than in the case of Park. So it's a one-shot game. It occurs only once from now for infinity. It is what is called impure strategies. So that means that you know exactly what you are doing or what the other ones are doing. It's not randomizing. They use a very particular function. All countries are symmetric and they focus on Nash Goodenough in one particular case. So the thing is that there have been dozens or probably hundreds of papers who have generalized this paper by Barron. And they have done it adding different bits and pieces. And in general, as long as the benefit cost function are concave convex, which is always the case in economics, the similar results hold. If you introduce asymmetric counters, it changes a little bit, but not much. So we still have the message that very small collisions are the only stable result. So, well, the more technical, if you use stackable assumption, it changes a bit, but again, it's probably not a relevant assumption. Multiple collisions can change this, but again, we haven't seen this in the past, but it can be, and I think that's something where we should study in the future. Multiple collision would be multiple agreements, not only one Kyoto Protocol, but multiple agreements. That's something that is not in this model, but that in theory would probably be interesting to explore further, as I will say at the beginning of my talk, at the end of my talk. Well, the thing is, what we are going to do is changing something very similar, basic. One is using mixed strategies that say that countries can randomize when they decide, and we explain why this makes sense. And more importantly, for those who that's why it's in the title, allow for gradual collision formation. So an expansion of the original collision. This was not the case for the Kyoto Protocol, but I will show now that this has been more generally the case in international environmental agreements, and we probably should have followed this path. So there are, of course, like always, related papers, but what you trust me, no one has done exactly what we are doing here. And I'm happy to discuss the relationship with the rest of the literature after I will ask a question. So as I said, so the Kyoto Protocol was a burden sharing agreement, but we stopped there. It was intended from the beginning as something that would be evolving over time. So the idea was that we will have an agreement only for developed countries initially from 2008 to 2012. There will be a bit of reduction. Then we will have a new one from 2012 to 2020, and so on. The idea was to have burden sharing agreements, one after the other one, in succession. The problem is what occurred, it was in 2009 when the time was arrived to do a new protocol. There was, some of you may remember, the negotiations in Copenhagen in 2009. And that it was simply not possible to reach an agreement. So basically, in the Kyoto Protocol had not been ratified by the United States. From the beginning, they were out, they signed, but they did never ratify. Then Canada left the agreement just basically a few months before. It was really clear they were going to abandon it. Then Australia said they were not interested in a successor of the Kyoto Protocol. Japan also signaled they were not really interested. So basically, at the end of the day, it was only the European Union and a few more small countries who actually signed a new Kyoto Protocol, which exists. It is a success of the protocol for 2012-2020, but it was not ratified by sufficient countries, and it was kind of abandoned. And with the world moved on first to the Cancun agreements, and afterwards to the Paris Agreement, which is a successor from the Cancun agreements, basically the same idea of pledges. So it was Obama who introduced this idea, a famous meeting with Chinese delegates, but soon the Indians were on board. So everyone was happy with this new system of pledge and review that I mentioned before. It has a big problem, as I mentioned, we have no guarantee that we're going to be paying it. So, but as I said, the Kyoto Protocol was supposed to be for the gradual process that was stopped just at the beginning, after the first protocol. But if you look into other international environmental agreements, it has actually been a gradual process. So in the Montreal Protocol on the ozone layer was a very big problem because it was detected to the end of the 80s, and it was basically an end life on Earth. If not stopped this, the ozone layer is a very thin layer of gas, very far high in the atmosphere, but it protects us so we don't get skin cancer. And it was discovered that our gases in our fridges and gases in the cars and the air conditioner and aerosols were destroying it, and that was a very big problem. So there was the ozone layer, there was the Montreal Protocol, which is seen as a success because we stopped the production of these gases, and we have basically solved this problem because the hole is closing. So it's known as the Montreal Protocol, but actually it's a set of protocols. So we have the 1987 protocol in Montreal, fair enough, but it continued in London, in Copenhagen, in Beijing, in Montreal, in Kigali. So we have a set of protocols that all fall within what we know Montreal Protocol. Similar story for the long-range transitory air pollution convention, where you increase over time, in different protocols, you become tougher and tougher. So the thing is, these protocols in general are not abandoned, and in general, they become tougher over time. So let's see what happened with the Montreal Protocol. This is supposed the Montreal Protocol. But in 1987, it was actually signed and ratified by a very small number of countries. Only these countries here that were initially were 5, but soon became 20. But it was a small number of countries that ratified. So it was actually not that different from what happened with the Kyoto Protocol initially. The difference is that the Kyoto Protocol was abandoned, and here the different protocols that I'm mentioning, so London, Copenhagen, Beijing, Montreal again, Kigali, they are the ones that you see here, the steps where more and more countries join. So it could have been the case for the Kyoto Protocol also that more and more countries joined, but it wasn't the case. It was stopped after the first step and changed by a completely different system. So here's that's in terms of number of countries, but of course, not only the number of parties is important, also the ambition. But again, here were the emissions of these gases which were destroying the ozone layer. So this would, without a protocol, we would have followed the black line, basically more and more of these gases, and we would have basically destroyed the ozone layer. The Montreal Protocol, the first one, the famous one, only reduced a little bit emissions. That was the goal with the Montreal Protocol. It was only when the London Protocol came in that we reduced it significantly, and only with the Copenhagen Protocol of 15 years later, 1992, where we really started reducing the emissions and practically bringing them to zero at the end. So this gradual process in the case of the Montreal Protocol worked very well. And what is important that usually said the Montreal Protocol worked, the Kyoto Protocol failed. But the thing is, what we forget is that in many cases, the Montreal Protocol worked through a gradual process. It was not a one-off case. So then what do we mean by mixed strategies? So mixed strategies is the second thing that we introduced in our model. And that's simply saying that you cannot be sure how others are playing. So in the basic model by Barrett, you know certainly how other ones are playing. But in reality, we have this uncertainty how other countries are going to be playing. And that's important, and that will change a lot of our results. So here what I'm saying, basically, that why should we use mixed strategies? Well, because we cannot be sure how other countries are going to have the policy in 5 years' time. Take the case of the United States. The United States, it is basically a random process what is going to be the policy in 5 years. Because we know that there will be an election coming. And with this election coming, it's basically a 50% chance. That's what I'm highlighting here. That red or blue comes out. It's a 50% chance roughly from today. And that means that we know the climate change policies could be completely different. So when the UK or the European Union is deciding their policy against the policy of the United States, they cannot be sure whether the policy of the United States will be tough or not, because we don't know the result of the next election. We know we can put different probabilities. We can say it's 60% blue and 40% red, but we cannot be sure what the result will be. And that means that we have to basically assume that they are randomizing. Of course, they're not really randomizing. It is not that the United States is randomizing the climate change policy. But our best way to understand what they're doing is to assume that they're randomizing, assume that the election is from our point of view, it's basically a random process with a given probability of red, a given probability of blue. And then we know red in the United States means basically no climate change policy, and blue means a strong climate change policy. So that's why I think introducing in this model mixed strategies is important because you have uncertainty about the behavior of the other countries. And that's one case where you should introduce it. There are also more technical reasons why you should introduce mixed strategies, simply because with mixed strategies, everyone is kind of randomizing at the end. And then how many countries, everyone, if they're symmetric, which is the case in the model by Barrett, well, everyone is using the same strategy, but they are not, you are cooperating with a 50%, not cooperating with a 50%. Everyone is doing that. And then who is really cooperating is kind of, you throw a dice or you throw a coin into the air. Right? And that's how you do the realization who is cooperating. On the contrary, with pure strategies, you have to decide that identical countries, some are going to stay in and some out. And that's very difficult to do if they're all identical. So I said before, we have the result that there are very few countries. You will see now that actually, to be more precise, with the simple model by Barrett, there are 2 or 3. So suppose there are 20 countries or 100 countries. Who are these 2 or 3? It's very difficult to know if they're going to be in pure strategies because then they have to decide from the beginning they are going to be the ones, but they're all identical. So that's a more technical reason. But it also explains why it is probably not good to analyze this in pure strategies that has been done in all the other papers. And then it's also what Benedict is a diplomat turned academic afterwards, who basically was in the negotiation of the ozone, the different protocols for the Montreal that followed after the Montreal Protocol. He wrote a big book about ozone diplomacy, explaining how the process worked and how it worked from the beginning, but all details, how this negotiation worked. And what he said is, one of the quotes from this book and also from other papers he has, is that academics tend to see it as a deterministic process, and it is not. It is a process where chance comes in very frequently. And he explains in his books many cases where it went well, but it could have gone very wrong. And it is a bit of a stochastic process, he argues, whether a protocol will finally work or not. And again, in a simple model as ours, the way to introduce this stochastically, the way to introduce that you really don't know what is going to be the negotiation position of the US or of any other country for that matter, is to assume that you have this mixed strategies. So then, as I say, our model is going to be extremely simple. We don't need to believe, of course, the number of 2 or 3 countries that will be our result. It is just the message, small number of countries. So for those of you interested in the technicalities, I'm happy to go into them. But the thing is, the message that one should get from these models is not only a coalition of 2 or 3. So an agreement of 2 or 3 is possible, because that's obviously not the case and also not in reality. Countries are not identical. There are many reasons why this is not realistic. It is just what economics frequently does in these cases. It gives you a hint of what incentives are and a general indication. An indication is that only small number of countries will agree, because afterwards the free riding incentives kicks in, and it is better to have others doing the effort than yourself. But anyway, to be more precise, here we have a function that we're assuming for gross payoff, where we have some benefits. We depend on the abatement done by all the countries, and some costs that depend on the abatement that you do. What does this mean? So you benefit from the emission reduction done by all countries, because we're reducing climate change. So you benefit from the abatement done by all countries, but you only have to pay for your own costs, for your own abatement. So climate policy in this model is costly, so you have to pay to reduce emissions. This may not be the case in the first stages, where you find situations where it's actually cost effective to change technology and even save some money. But if you really want to have a strong climate change policy that brings you down to net zero, then it is costly. All models suggest that. So it's reasonable to assume that it has cost to reduce your emissions. So this model by Barrett simplifies a lot of things and assumes that you have 2 stages basically, where you decide whether you will be part of the agreement or not. So it is a participation stage. You decide I want to join or not. And if you're part of the agreement, then you will all work together and decide commonly what the abatement will be of all the members of the coalition. It's a very strong assumption. So they're really jointly. So it is more like, so you're really in an organization where you're taking everything together afterwards, the decision on how to abate. This is a strong assumption, and it's definitely closer to the Kyoto Protocol, in the sense that once you decide you are in, you're negotiating with the other parties how much each of the parties are going to be negotiating. So that's how we have to see it. It's not a good representation of the Paris Agreement in itself. On the pledge part, maybe of Article 6, but not of the pledge part. It was a better representation of the Kyoto Protocol. And then it's a supreme perfect equilibrium in pure strategies. So again, here starts some math, and we can ignore it. So what are we doing well, first we go backward. We first solve what countries want to emit given that the number of players in the coalition. But more importantly, we check for what is called internal external stability. So we're looking for a situation where no country wants to leave the treaty, which is called internal stability, and no country wants to join the treaty, which is called external stability. Together they give us stability. What does it mean? It's simply we're looking for a treaty where if it's signed by 5, no one wants to leave, reduce it to a treaty of 4, and no other country wants to join and make it a treaty of 6. So that's what we consider a treaty that is stable, because no one wants to go in or out. So we're looking for stable treaties in that sense. And that's the one that we're going to be showing. It's only 2 of them. So here is how you do this. Well, it goes mathematically. If anyone wants to ask afterwards, we go back to this. But basically, we have these functions. It implies that they have to be positive. And we see here they are both positive. Internal and external stability only work here in this small area between 2 and 3 countries. And what's more important, that doesn't hold only for 5 countries. It will hold only for 100 countries. It doesn't matter how many countries are, because this thing becomes negative. You're only going to have a coalition of 2 or 3, or an agreement of 2 or 3. What happens above 3? What happens is that what fades is internal stability. That means that countries want to leave. And why do you want to leave? Because if you're in a coalition of 6, it is better to leave and let it a coalition or an agreement of 4 or 5, and you will be an outsider and you will be enjoying the effort that others are doing. Because remember, the benefit is just a function of what everyone is doing. So if you're in a coalition, if there's a coalition of 20 countries, it's always better to leave and to let the other 19 do the effort. In a coalition of 6, it's the same. It's better to be outside and wait. Only in a small coalition of 2 or 3, it's better to stay in. So of course, that's a very pessimistic result, and that's the main message that came out from this analysis and from a lot of this literature. That we have a very negative result. So this is what we have. They are doing this emission here, modest emission, and only 2 or 3 countries in the so they also it's also in terms, it's not only in terms of number, it's also modest in terms of effort. We saw before that on the gradual process in the Montreal Protocol, the number of countries increased and also the effort increased. We will see here the same. So in this one-shot thing, we have a very modest. This is 2 or 3 times B over C is modest, because B over C is what you do when you're independent. And then it becomes more and more when you increase the gradual process. So here's the technicality of how to do the gradual process with the mixed strategy. So there's one shot with a mixed strategy. I will skip that. It is that's also skip the here. I just left the graphs if someone wants in the questions to come back to them. Again, this is the proposition how it looks. But what is important now, it's simply saying everyone joins with a probability, which is given by this number here. Everyone joins this agreement with a given probability. So we are not anymore in the situation where we just pick 2 out of, we don't know exactly how. Here, everyone is playing with a probability, and that's what's going to happen. What is the result? Well, actually, it doesn't change a lot, because it's going to be depending on the number of countries, 2 or 3. So basically, also this mixed strategies gives us basically the same result. Again, the negative thing, it is not because we introduced these mixed strategies. It is not because we assume now that others don't play randomly, like we said for the US, that we solve the problem. We're still at this very small coalition. So now we introduce the gradual process. So here's some notation. I don't think we need to go into that detail. What is important is that now we have the situation of the Montreal Protocol. We signed in 87, 5 countries. 3 in our case, because, well, all identical, we have seen that only 3 will sign. 3 have signed, but now 5 years later, or 10 years later, they go back to the negotiation table, and now they discuss whether new countries should join or not. And then afterwards, they discuss whether new countries should join or not, and it expands gradually like that. Whether this process can work or not in a model which is designed to be almost identical to the model by Barrett. So we only introduced this mixed strategy, which didn't change much of the results, and now we're introducing this gradual process, whether this can work. And then, yes, this is how it works technically, but basically this function here tells you something which I will explain better graphically. So here we are on the countries, this M is the countries that will join, that are in the previous coalition. And how many will join initially is the X here. So what does it mean? If we have no coalition initially, so every coalition of one country is the same as no coalition, because if you're alone, well, that's not coalition. Then how many countries can join? 3 or 2? Exactly the result that Barrett found. If we have no previous coalition, only 2 or 3 can join. So we'll have a very small coalition. But what are we saying now? We're saying that if you already have a coalition of 3, the one that you formed here, now any number below this line can join. So you can have 4 countries joining, 3 countries joining, 2 countries joining. And then, for example, if 4 join, you will end up with a coalition of 7 in the second one. And now in the 7, any number below here can be joining. So 6, 5, 4, all this can join. So you can have 6 more joining, and then you end up a collision of 12. So you can have this gradual process that we have seen in the Montreal Protocol. It can happen in this model as well. And also the same that happened in the Montreal Protocol, we have the situation where in each round, when you expand, you become more ambitious because you're doing more times what the singletons would doing outside. So the problem is we have, if we use these pure strategies, as Barry did, we forget about this thing that you have to randomize, then basically what happens is that there are too many options. So as I said, here, if you're a collision of 5, 5 can join, 4 can join, 3 can join, 2 can join. So you don't really know how, you know it is going to be expanding until the grand collision is achieved, but you don't know if it's going to be a fast thing or slow. So it can be as fast as 7 rounds to get 200 countries, would be first 6, then 4, then 6, then 10. These are the ones counted joining. So once you have all those at the end, you have all the 100 countries in 7 rounds. But it could also be in 99 rounds, 1 by 1 joining. Then, of course, if you have negotiations every 10 years and you need 99 rounds, well, then basically it's centuries to finish this thing. So it is a big difference whether you're here or here. So we know we are going to go towards the grand collision, like happened with the Montreal Protocol, but we don't know if it's going to be fast or slow, and we have too many options open with these pure strategies. That's why we introduced this idea of mixed strategies that allows us, again, the technicality looks awful, but the thing is now we pick up one particular path. We're not saying anymore any path is possible. We say this is the most realistic path that we have in expectation. And it is actually quite fast. So it makes it not in the 7 rounds, which was the fastest, but in 8 rounds. And we argue that this is the most reasonable path that you should expect within this model, which is a path that goes close to the fastest possible. If we look at the graph that we had before, the line is the fastest possible expansion in each moment. The red dots is the one in mixed strategies. So you're close to the fastest possible. And we argue that this is the most, in the paper, we argue that the mixed strategies, as I said also before, is probably the most reasonable one. So you have, first of all, you have a clear message how it would evolve. And it is positive. It will bring you to the grand collision. One thing that I have not really focused is that I was assuming it was on the top here, but it was not seen, that I am assuming irreversible collisions. What does it mean? And is this possible? Not really. Irreversible collision means that once you are in, you cannot leave. And we know from, for example, even one of the European Union is an international treaty, and it was an international treaty where it's very difficult to leave. But we know from Brexit that it is possible to leave. So making it fully irreversible is not reasonable. If it would be reasonable, if we could have an agreement that is fully irreversible, then we would achieve the grand collision. The problem would be solved. But the thing is that if it's completely reversible, that you can leave in any moment without any cost, then we're back to the results by Barrett that only 2 or 3 will hold. So then we said ourselves, well, that's quite disappointing. But in reality, of course, we are somewhere in between. So leaving an agreement is complicated. Brexit has been complicated. You can argue it's positive or negative, but it's complicated. And some agreements are more difficult to leave than others. The European Union is particularly difficult to leave because it was a market which was very integrated. In the kind of climate change, if you're within an emission trading system, it is harder to leave it than if you're not within an emission trading system, a common emission trading system. So you can make it more or less reversible. And assuming that it's fully reversible and that whenever you expand the European Union, all countries consider whether they leave, it's also not realistic. So now when the European Union negotiated the expansion to, to Romania, it is also not realistic to assume that every single country was considering the possibility of leaving. The United Kingdom was, because it's possible, but not every single country in the European Union. So we said, okay, the fully reversible is not reasonable, the fully reversible also not. Well, let's make a parameter that gives us something in between. And that's what we did. We said, let's make a parameter alpha that gives you the completely irreversible with 0 and completely reversible with 1, so that we can move it around and see how this affects. Whether the result that we go back to the 2 or 3 maximum, it really hinges on making it completely irreversible. And now it turns out not. So you can actually, you can expand it on some parameters. But going back to our example here with 100 countries, what happens is that as you increase the reversibility, the process stops earlier. So you go to the grand collision following this path of alpha 0. It's completely irreversible, remember? If you increase irreversibility, you're following the same path, but you stop earlier. If you increase it, it stops earlier and earlier. Looking at our graph before, that means that if you are completely reversible, so if you would make something where international treaty where Brexit is not possible, this would continue until the grand collision is reached. If you make it more reversible, easier to get out, it will stop here or here or here. You know where it will stop this process. Remember, this means that 2 join here, 3 join here, basically 5 join here, 5 join here. You can stop, it can go on, or you will stop it, depending on how reversible you are. So the message is this agreement should be as irreversible as possible. We are aware that cannot be fully irreversible, but one should make them as irreversible as possible. Here's a summary of what we get there as comparing the reversible with pure complete strategies. And here's my, concluding already, my key messages to come in. So this influential paper by Barrett is very pessimistic results. They had a lasting influence on these negotiations. I really believe it because I have heard this argument in many instances, not only from economists. They actually, it is, as I've seen, it is really hinging on having only one step, not allowing for a gradual process. They also use these pure strategies, which give multiple equilibria. In our gradual process, that becomes a complete mess. That's why we think the mixed strategies are better. It gives you one unique equilibrium and completely mixed strategies. But what's more important, this gradual process with partially reversible collisions, so the realistic one, implies that you are increasing the number of members as you increase gradually, and you're increasing the ambition as you increase gradually. Because you're not able to be completely irreversible, the process may stop before reaching the grand collision. It would not reach stop if you were completely irreversible. So being as irreversible as possible is good. So this would be everything up to now would be an argument to follow the path of the Kyoto Protocol. Probably we should have followed the path of the Kyoto Protocol as a world and gradually increasing it the same way that we did with the Montreal Protocol. But the thing is now it's too late for that. So we are in the Paris Agreement, that there we will stay. But within the Paris Agreement, we still have the option of doing this gradual process with Article 6. That means the United Kingdom and several countries of the South can make an agreement, and they can expand it afterwards and hope that it will be growing over time. So in comparison to 2022, in another paper, I analyzed a set of bilateral agreements, like the example that we had between Switzerland and Peru and Switzerland and Ghana. But one could also have, here we are analyzing one single gradual expansion. What is probably more realistic is once you abandon the Kyoto Protocol, because this is realistic for the Kyoto Protocol because there is only one that your increase is really, only one is increased. But now within the Article 6 of the Paris Agreement, it's probably more realistic to assume that there are multiple agreements that expand gradually over time. And that would be more my way forward. And probably also the next paper I will be writing is the multiple agreements moving forward. Because I really think if we don't have these multiple gradual agreements moving forward, we will have a very hard time stopping this trend, and we will have a very hard time doing this orange part and even the blue part. We will stay at the gray part, and that will definitely not solve the problem. So, questions, and I'm happy. Thank you very much for your attention.
Thank you so much, Alejandro. That was fascinating. Does anybody have any questions that they would like to ask? Feel free to just put your hand up or pop it in the chat or.
Ask a question, Kate.
Yes, please do, Laura. Yes.
It's Laura here. Thank you, Alejandro. You've been, a very good talk, especially for non-expert. And you know that I specialize more on mechanism of carbon control, such as market and non-market based instruments of carbon control. And I was wondering whether this emphasis from Article 6 on carbon trading might lead to endogenous coalition formation, because typically one is thinking, okay, first we have the coalition and then we implement the instruments, right? Think about carbon trading. But can this process go the other way around? So first, the markets sort the carbon trading schemes, for example, especially at global level, hopefully at global level. and then coalitions are formed because the markets require to do so. Thank you.
Yes, thank you very much for the question. And yes, I mean, so the way forward I see to be, I mean, I wasn't very precise on this point because I wasn't developing that, but I fully agree it's through emission trading that we will probably have that. But I think what the model would be suggesting more is that you have different emission trading that evolved, that are created independently, like the one of the European Union, the one of Switzerland, the one of the UK, the one in Canada, and then you link them, and that's how you expand it gradually. So basically, it's through the emission trading systems that you're linking, that you're expanding these coalitions. Up to now, we only have one example that the European Union has integrated the Swiss emission trading system, so they became one. So the thing is, it would be good to one way of doing this within Article 6 would be to link emission trading systems, and that would be go very much in what you are saying, that basically it becomes an endogenous process, because emission trading systems only work properly when there are big differences in terms of cost and benefits between firms. And the larger you make it, the more attractive it becomes. So it may be a way forward to do it through linking of emission trading system, as you suggested. Yes.
And are there any papers on this?
There is a paper, or there are a couple of papers on what one is called carbon dating. They are on emission trading, on linking of emission trading systems. And they call it carbon dating because it's basically that they try to select which emission trading systems are more prone to gain more from becoming one. Okay. So you're seeing you have a set of emission trading systems in place, and you try to see which ones are benefiting more from getting together.
All right. That's great. A curious title, although carbon dating. Yes, I like it. Thank you.
I send you the reference.
Thank you.
Thank you.
Thanks, Laura. Does anybody else have any questions? I have one in the meantime, if I ask mine. So I just had a general question, Alejandro, which is, are you optimistic about whether the IPCC is going to be able to put together agreements or bilateral agreements or agreements under the Article 6, I think you said it's called, that this is actually going to work? How optimistic are you that we'd be able to actually do this and be able to restrict emissions to, well, 1.5 or 2 degrees?
Yes, I really see we have a problem. So because climate change in many countries, including the UK, the European Union, is a big issue right now, and we're tackling it. But we are really focusing right now only on doing it nationally. And I think that will only bring us so far, because there are many other countries which are not so interested or which don't have the means to do it. And if we don't integrate that, we will be, well, focusing on the gray part in this graph here I'm sharing. So so I'm optimistic that a group of countries will be able to go to net zero in 2050. I'm not so optimistic that the world is going to be able to go to net zero by 2050. And that is, of course, what matters, whether the world is going to be able to do it. And for that to happen, I think we would need to put back on the table the international cooperation much clearer than we are doing it right now.